and the cerebellum, which is crucial for balance and motor development. It is currently thought that accelerated brain growth causes neurons to over or underdevelop. As well as this, accelerated brain growth results in poor brain organization, with the main impact being an inability for brain regions and structures to effectively communicate and function through normal brain networks, systems, and subsystems. The largest functional difference in individuals with ASD is connectivity. Connectivity is a broad concept encompassing physical interconnections as well as correlations or causal interactions in activity of different brain regions. Brain connectivity measures infer which brain regions are physically or functionally connected to form brain networks that serve cognitive and behavioral task performance. Findings are generally consistent in showing a pattern of overall brain underconnectivity coupled with local overconnectivity within specific regions, often in the frontal and occipital regions. This assists in the explanation of issues related to understanding things such as facial recognition and emotions, as well as finding specific sensory information overwhelming compared to individuals without ASD. From this, it starts to build an understanding as to why individuals with ASD find it hard to communicate and socialize. Underconnectivity results in inhibited ability of the brain to process information or initiate movement correctly. Firstly, as previously discussed, the abnormal development of white matter within the brain causes poor neural network organization and in turn poor ability for specific brain regions to connect and communicate in both short and long range networks. This is commonly seen in areas such as the corpus callosum, which is responsible for interhemispheric connection. Also highlighted was the poor and abnormal development of neurons. Most significant is the synaptic dysfunction, which relates directly to a neuron's ability to excite or inhibit specific actions or stimuli. Research has revealed a significant imbalance in the ratio of major excitatory and inhibitory neurotransmitters. Commonly found in ASD individuals is an excess or overactivation of glutamate and dopamine, two key excitatory neurotransmitters. Secondly, research has also highlighted a reduced amount of and effectiveness of GABA, a key inhibitory neurotransmitter. This results in a more excitable and weakly inhibited cortex, which functionally speaking leads to broad-ranging abnormalities in perception, memory, cognition, motor control, and seizures commonly found in individuals with ASD. Looking to the future, there is still a lot of growth that is needed in understanding the cause of ASD. Although considerable research has been conducted to understand the mechanisms of what happens in the brain of individuals with ASD, it is still not known what the cause is. This results in limited treatment methods. Currently, treatment uses some medications to manage behavior and other comorbidities such as epilepsy, and seeing specialists such as occupational and speech therapists to assist in an individual's social development. One confronting area of necessary research and development is the strongly believed hypothesis that current diagnostic methods camouflage autistic traits in females and favour male outcomes, causing a lower perceived prevalence in females of all ages.